Hi pre-calc students, this is Ms. Trevsker and I will be completing pages 3 and 4 of your reviews. This is page 3. So when we're asked to graph the following functions, say the domain, range, and equation of the asymptote, for the first one, 21, we are asked to graph a log function. Well, the inverse of a log function, or of logs, are exponential functions. So the first thing we are going to do is we are going to graph the parent function of the exponential. So my base is 3. So my parent exponential function is going to be y equals 3 to the x. So I'm going to make a table of values. So I have my x, my y, and then I'm just going to pick 3 points for my x. It doesn't matter what 3, but picking 3 points really gives us a good idea of the behavior of the graph, what it looks like. So I'm just going to pick -1, 0, and 1. So when we evaluate the function at -1, 3 to the -1, that is 1/3. 3 to the 0 is 1, and 3 to the first power is 3. Okay, now since exponential and log functions are inverses, my parent function for my log is log base 3 of x. So when I make the table of values for my log function, I am swapping the x and y since they're inverses. So my x values are going to be 1/3, 1, and 3, while my new y values for the function are going to be -1, 0, and 1. Okay, now that I have found the inverse of my exponential, now I'm going to apply my transformation. So I'm going to make a third table. Okay, so whenever we, when we talk about transforming the x values, we want to look at the inside of the function, because the inside of the function affects the graph horizontally. So the -1 actually is going to shift the graph to the left 1, so it's going to be x minus 1. And my y value, we have the -2, so it's going to move my function down 2, so it's going to be y minus 2. So I'm going to look at my x values, my y values of this table right here. And I'm going to subtract 1 from all the x's and subtract 2 from all the y's. So 1/3 minus 1 is -2/3. 1 minus 1 is 0. And then 3 minus 1 is 2. Now for the y values, -1 minus 2 is -3. 0 minus 2 is -2. And 1 minus 2 is -1. Let me just double check those points, make sure that they are correct. Yes, they are. Okay, now let's go ahead and graph the function. So first I'm going to graph my asymptote, because that'll just give me a good idea to double check my points to make sure that they're right. Since log functions have vertical asymptotes, so the parent function has a asymptote at x equals 0, the shift 1 to the left is now going to cause my asymptote to be at x equals -1. So I'm first going to sketch or just draw my asymptote. So x equals -1, that is a vertical line. I'm not very good at drawing straight. There we go. So there is my asymptote. Now I'm going to plot my points. So my points are -2/3 and -3. So -2/3, somewhere between 0 and -1, and -3. 1, 2, 3. 0, -2. And 2, -1. Okay, so it's going to be approaching the asymptote. And there we go. There is my graph. So if you look at the graph, my domain is going to be -1 to infinity. And my range is going to be -infinity to +infinity. Okay, now for question number 22. So let's go ahead and let's make a table of values for my exponential function. All right, so here we go. Table of values for y equals, so my base is 1/2, so my parent function is going to be, sorry, my base is not 1/2, my base is 4. So my parent function is going to be y equals 4 to the x. So if I make a table of values, x, y, I'm just going to use the same ones as before, -1, 0, and 1. See, that's going to be 1/4, 1, and 4. Now I'm going to transform my values. So anything on the inside of the function affects my x values, but if you look at the inside of the function right here, nothing has changed. So my x values are going to stay the same. I'm going to look at the outside of my function, and that affects my y values. So I have the 1/2, and I have the -2. So I'm going to take my y values, I'm going to multiply them by 1/2, then I'm going to subtract 2. So my x values are going to stay the same, so it's going to be -1, 0, and 1, and then my y values are going to change. So we have 1/4 times 1/2, that is 1/8 minus 2, that is -1.875, just because I'm looking at the answer key. Then we take 1/2 times 1 minus 2. That one you can do in your head. That's -1.5. And then we have 1/2 times 4. That's 2. 2 minus 2 is 0. Okay, now let's go ahead and graph this. Before I graph it, though, I'm going to determine what my asymptote is. So because exponential functions have horizontal asymptotes, anything on the outside of the function is going to shift it or affect it vertically. And so that -2 is going to shift my asymptote from 0 down to -2. So I'm going to go ahead and first draw my horizontal asymptote. Okay, and my horizontal asymptote is at y equals -2. Okay, now I'm going to plot my points. All right, so my first point is at -1, -1.8, -1, -1.8. Next point is at 0, -1.5, 0, -1.5. Next one, no, that's not perfect, but that suffices. The next one's at 1, 0. So again, it's going to approach your asymptote. All right, there we go. So there's the graph for 22. All right, now next, another log function. So the parent function of this log function is, since the base is 2, the parent function of the inverse, so the exponential function, is 2, so it's going to be y equals 2 to the x. So I'm going to make an xy table. I'm going to pick 3 values. So I have 1/2, 1, and 2. Then I'm going to write the parent function of my log function. So I have y equals log base 2 of x. Because these are inverses, I'm going to swap my x and my y's. So my x values are 1/2, 1, and 2. My y values are -1, 0, and 1. Now I'm going to apply my transformations. All right, so anything on the inside of the function affects my x values. So if we look on the inside of the function right here, nothing has changed. from the parent function. So my x values are going to stay the same. Then let's look on the outside for our y value. So outside the function, I have a negative and I have a plus 3. So my y values are going to be transformed to negative y plus 3. So my x values are 1/2, 1, 2, and then let's see, 1 plus 3 is 4, 0 plus 3 is 3, negative 1 plus 3 is 2. Okay, so let's talk about this graph for a second. So this is going to be shifted up 3 units, and the negative in front, that is going to reflect it vertically. So that's going to be reflected over the x-axis. So when we graph our function, we need to make sure that it is in fact being reflected. Okay, so let's go ahead and graph. Okay, so first I'm going to sketch my asymptote since there is no, oh wait, did I do the domain and range on the other one? Oh dear, what just happened? All right, no I did not. Let's hop back up to 22 for a second. My domain is negative infinity to positive infinity, and my range is -2 to infinity. All right, let's hop back down. Okay, so since there's no change horizontally, my vertical asymptote is going to be at 0. So my vertical asymptote is x equals 0. Okay, now I'm going to plot my point. So x is 1/2, y is 4, 1, 2, 3, 4. 1, 3, and 2, 2. Okay, there is my graph. So my domain is 0 to infinity, and then my range is negative infinity to positive infinity. Okay, last question on page number 3. So the next one is going to be graphing y equals e to the x minus 3 plus 1. So first I'm going to make a table of values for my parent function, which is y equals e to the x. Now what does e equal? E is approximately 817, something like that. It's approximately 3. So we're going to pick 3 values, -1, 0, 1. So y is approximately going to be 1/3. E to the 0 power is 1, and then e to the first power is approximately 3. Now we are going to transform our values. So when we transform, we look on the inside of the function for our x value. So we look on the inside of the function right here. We have x minus 3. So that is going to affect it horizontally. But remember, we have to do the opposite. So we're going to do x plus 3. Then we'll look on the outside of the function, and that affects our y values. That affects it vertically. So we have y plus 1. So our final value table of values is going to be 2, 3, and 4. And then my y values are going to be approximately 1 and 1/3, 2, and approximately 4. Now when we have exponential functions, we have horizontal asymptotes. So because my function was shifted up 1 unit, my horizontal asymptote is y equals 1. So let's go ahead and draw that in first. Do purple this time. Okay, and then we can plot the points. So when I'm plotting my points, I have 2, and approximately 1 1/3. I have 3, 2. Whoops, 3 2's right here. Sorry. And then 4 4. 1 2 3 4. 1 2 3 4. Remember, it approaches the asymptote. And up. So my domain is negative infinity to positive infinity, and my range is positive 1 to infinity. And there you have it. There is page 3, and there is my lovely graph.